Hello everyone, my name is Abhishek and our team consists of Priyanka and Mohit, and the topic that we have chosen is Golang. Um, Golang is a programming language, is an open source programming language which was developed at Google by Robert Griesmeier, Rob Pike, and Ken Thompson in 2007. Um, it is very simple. It is fast and it is a very reliable software when it comes to scaling and its other features. So there will be a couple of things that we'll talk about today, which are I already introduced you to the language, why you should choose Go, and what are its features, what is a Go routine, how the communication happens between Go routines. Some interesting features again, language design, web app support, and the language's pros and cons, and how it's compared to other contemporary languages like C++, Python, Java, and Node.js. All right, so why Go? So Go was built with the sole purpose of bringing concurrency and helping people to develop concurrent models of their systems without doing extra work or extra integration of other languages and frameworks. So far, none of the languages have proven useful or as useful as Go has proven. So Go um, was built with, as I said, the sole purpose of bringing concurrency into picture. So it has built-in concurrency, which is great. It is strictly and strongly typed language, which in turn is less or has less or none runtime errors, which is a great thing. Your production server can run without any problems and you can push your code once you have tested. Other interesting features Go has is a Go routine and speed and ease of deployment. So I'd like to talk about more what it means by concurrency. So large programs are often made up of small programs. For example, a web server handles requests made from web browser and serves HTML web pages in response. Each program is handled like a small program. It would be ideal for a program like it can be able to run smaller components at same time. Okay, so making progress on more than one task simultaneously is known as concurrency. And Go has rich support for concurrency using Go routines and channels, which we will talk about in further slides. So there's a slight misconception or slight confusion of the difference between concurrency and parallelism. So parallelism is when two or more threads are executing code simultaneously against a different process in different processors, where in concurrency are different Go routines running in a single processor. So what concurrency does is, and what Go does is, when you create uh, okay, so we'll talk about Go routine over here. So Go routines are lightweight threads actually, and they are managed by Go at runtime. And what happens is, when you make a Go routine and when you have to scale or when a number of processes are spawned, um, instead of duplicating processes in different processors, what Go does is it creates copies of different threads in a single processor. Now, due to this, there are a lot of advantages, like there is an ease of memory sharing, and because it's not in different processors, there are not extra calls to manage the data and manage the state of the database um, with Go routines. So since Go routines are are pretty lightweight, they are easy to scale and don't put extra load on the processor they are running on, even when they are scaled to thousands of numbers. Okay, so the way Go routine works is, it is prefixed. Any function that you prefix with the words Go, um, that becomes a Go routine, and Go understands that this is a Go routine. So this is a small example. Say you have a main function. Go has a main function, and I'll talk more about the code structure in the demos we have and the sample code that we have. um, so what this is making is, C is a channel, okay, and Go has a weird syntax where uh, the variable name or the parameter name comes first, and then its type, and then it mentions the type. You have to mention the type. So channel is the variable name, or it, oh sorry, in this case, both channel and string are types. So this is a channel of type string. We'll talk about channel in the next section. And so C is the variable or the channel string channel variable that you get by by calling this function make. This creates a channel. And now once you've made the channel, you can just say read what is a function which reads from some input stream or console function or a console input. And once you give it a channel, and you can then, once you say go, because go routines need channel for communication. If you don't have a channel, and you just have the prefix go, it will be a go routine without any communication to other parts of the go routines or other go routines, right? So channels are needed for communication. um, all right, so channel, they are the medium of communication between two go routines and then synchronization. And as I said, if you don't have a channel or you don't provide a channel to a function, it becomes usually difficult, or I don't think even if it's possible to send you know data through without channels, because with channels you establish a communication or a pipeline between two go routines or any number of go routines that are using that channel. And both the go routines or the other go routines can start sending data and receiving data through that pipe. And hence, because of these channels, they are like web sockets. So once you establish a connection and the initial handshake is confirmed, you don't have to do any extra calls to send or receive data. Compared to this, contemporary APIs are stateless, and hence on every request the client has to identify itself either with access tokens or authorization headers, so the server knows who is which process or which client is making the request, even if it's the same client making successive requests. So channels are useful that way. And this is the keyword, or this is the symbol used in Go to send and receive channels. So when the arrow is towards the channel variable C that we made over here, so once the channel is towards the channel, facing towards the channel, it means the data is being sent through the data is being sent through the channel. And when you're receiving the channel, the arrow or the symbol is coming out of the channel. And this is how assignment works in Go. And once, if you want to see, you can print the message to see the output of this code. Yeah, so this is an example. So FMT is the utility package that comes along with Go. Time is another package. This is a function hello, where C is of type channel and of type string channel to say, and it is sending hello through the channel. And there's another function print, which is also a string channel and is receiving a function through the channel and is storing in the variable message. And this is how you print a message on in Go. um, and this is the main function which actually runs. So you make a channel called C, which will be a string channel, and you make that channel and you call both the functions. So once you call the function, they are both using the same channels. As you see, we both pass C. Now what happens if print runs first and hello doesn't run? So the print function is trying to read something from channel, but the hello function hasn't sent anything. So this synchronization and this happens with Go routines, and the channels help that. So if a channel is receiving from something and a channel is empty, it will wait for the sender to send the messages until until and it'll wait until it receives something through the channel. So even if the functions start executing at different times, they will wait for each other to synchronize and then start execution. Interesting features. So this was really surprising for me to have come from, programming backgrounds like Python, JavaScript, and Java. That Go did not have a class keyword. Instead, it has a struct keyword. And Go also doesn't support inheritance. It has interfaces, which you can um, store as types, or inherit, not inherit, but kind of form structure to your function. It provides structure to your function like interfaces do usually. Go's compiler is super fast. It's easy to compile large program easily because of the simple syntax. Since Go is strictly typed, once you compile a language, the execution is very, very fast. And Go has no extra dependencies for simple tasks, right? So Go has a lot of inbuilt packages to support, so your program is even faster, and you don't have to wait on extra packages and the versioning of the packages and maintain those versions. So due to that, Go is really fast while execution. So this is another example. Like, this is an employee struct with a name and an age parameter, which is string and int, and this is a function called talk. Which, so what is happening over here is the left side of the function name is the input or the parameter that it will get passed, and the right side of the function is its output. So you see, it is strictly typed. You cannot send anything else except the employee type or employee struct, and it will only output string. If you try to output a number, it'll throw an error. If you try to output anything else, or an object for that matter, except the string, it will throw an error. This code will throw an error, right? So this is taking a type of employee, which is then printing its name and phrase. So this is a general object oriented parameter, object oriented method using the dot operator. So over here we are making a new employee, or a new object of the employee struct with parameters Priyanka and her age. um, and then we call the function talk, which is on the employee struct because it's inheriting, from the employee class, from the employee type or the employee struct. And then you can pass in the phrase which is expected over here. Okay, so I was slightly wrong before. What is happening over here is the phrase is what is expected of the input, and employee, this line of code means it is part of the employee struct, or it is a function attached to the employee struct, and that is why we can call employee.talk and then say go. Yeah, let's see, language design. So it is simple and safe. It is one sec, let me finish this. Yeah, so it's simple and safe. Definitely it is it is extremely simple, and you will be surprised to see the amount of lines, or very few lines of code that you have to write to achieve some pretty complex tasks. Okay, so also it is concise and readable, because it was Go was made with keeping in mind the simplicity, to simplify the process of concurrency and scaling. It is very concise. The source code is very concise, is very readable. It has, as we talked about, it has pretty fast compilation time, and it can return multiple values, which is great. If you want to return multiple values, you just say return, and pass in whatever type. Just mention whatever type or variables that you want to return from the function. Installing packages is happening with go get. So you say go get and you say a package name from GitHub or any other repository on Go, or the Go's package manager. So this is go get is kind of package manager for Go. You say go get and say the package name, and it installs that package in your Go root directory. It is obviously suitable for parallel programming that we have talked about, and it has support of a large variety of built-in types, from integer, like 8-bit integers, to 16 to 32 to 64 bits to 128 bits too. Okay, so Go has a lot of support for web apps, and it is it comes along with a lot of inbuilt packages, which is great. So Go has packages for HTTP, URL routing, cookie handling, templating, handling JSON data or XML data, and popular support for SQL and PostgreSQL frameworks. It has packages for testing, and it is simpler. Uh, we have a small demo on a web app, and I'll also show you the code for that. Uh, it was pretty simple. It was pretty simple to make a website or a web app only with one handler and a one static page. It was nice to work with it. So language is pros. It is fast and friendly. It is traditionally coming from C because of its strongly typed interfaces and languages, strongly typed framework, or the environment. Um, it is very much used in automation, and it is callback free. So if you have heard about callback hell, that is a popular problem right now with JavaScript engines. We'll talk about more about that in JavaScript, in Node.js versus Go. It has garbage collection. It has memory management, like Java and C++ and C languages. It is multi-platform and portable. So once you have executed Go, you can take that code and run anywhere on any server. So let's see, concurrency benefits. Yes, it is concurrent. It is obviously benefit for concurrent processes, running concurrent processes, and it has backing from Google and definitely has a bright future. So one of the cons of the language is also callback free syntax, which is kind of weird because sometimes you need to uh, you know have callbacks on certain things. um, I cannot imagine an example right now, but say you have an event happening, okay, and if it was Go, you could make channels, and just wait. The receiver process or receiver function is waiting for an event happening over that channel, and it might not happen. But the same thing happens with JavaScript, or you can have event delegation, so you don't have to the function which is tasked to execute, or to handle that event, doesn't have to wait for that event to happen. Once that event happens, the environment, the JavaScript engine automatically dispatches an event, and the function receives that event, and it handles or processes it. So sometimes this could be a problem. There is no virtual machine. It becomes difficult in place of making simpler. So obviously there are problems to as to what level of simplicity Go is bringing into market. Some might feel it is even more difficult to learn Go if they are from other traditional programming languages background. It can be difficult to learn Go. It is a young language and a young ecosystem, and it is gaining popularity though. So Go does not use header files like C++ does, but you have structs, which is okay. It provides automation and automatic garbage collection, Go does not support function overloading, which is a great feature in C++, I believe. It does not support user-defined operators. So this is the same as operator overloading. Um, Go focuses on concurrency and quick compiling. So Go versus Java. Go is strictly typed like Java. Interfaces are very simple in Go. Um, uh, Strictly typed in Java, as in we have interfaces in Java and in Go too. Because of that, both these languages are very less error prone after they are executed, after they are compiled, once they are compiled. And Java is an enterprise development language, but Go is a system programming language, a scripting language, more used on the DevOps side than on or a UI UX or a web app side, or the application side. Java doesn't support things similar to Go routines, so yeah, Java doesn't support concurrency, and you can obviously do implement TCP models with Java or do network programming with Java, but uh, it can be quite a daunting task, which is very simple with Go routines. Also, Java doesn't support return of more than one value, which Go does, and Go compiles to native machine code, and I think Java compiles to a class file which can only run if a JVM is there. But what Go does is once you compile, it compiles to a native machine code, so you can take that class file or the object file that generates out of the compilation and run that on any similar OS, which is great without having Go installed on it. Go versus Python. So Go is a compiled language, as we talked about earlier, and Python is an interpreted. It is a dynamic language, and it is more error prone. Like languages like these are more error prone during runtimes. Go being a system oriented language is a faster choice, and Go has no classes or subclasses, which is obvious. We talked about it like in Python. Concurrence is built in Go. Now Node.js is extremely popular framework these days, and a lot of popular companies are using it. So support for concurrency, Node.js is struggling to bring concurrency into their framework. I think Node 7 version 7.2 or 7.7.2 has support for async and await, which are usually called async generators, and which do a similar task of what Go routine do with channels. So you can label a function as async, and say you have a API call which will take some time. If you know about promises, it returns a promise which takes some time to resolve. You can label that function as await, and JavaScript engine will continue execution of the rest of the program and wait for until it gets the data from the promise, until the promise is resolved. So this thing happens with Go too. You have channels, and you send data or wait for the data to be sent. So but this is still new in Node.js, and I don't know how useful it will be. Go can be difficult to adapt and learn for developers coming from different JavaScript frameworks background, and there are different concepts to be learned, particularly with Go, like Go routines, and type inheritance. Go is pretty fast due to Node.js's Go is pretty fast, but due to Node.js's dynamically typed nature, it can never reach raw CPU performance like Go can, which is obviously the point of building Go. Go was designed to ease the process of scalability and concurrency, whereas many companies using Node have complained that Node doesn't perform well when massive scaling is expected. And since Google was building it, I believe Google built it with inherent features for scaling and concurrency. So thank you very much, and I'd like to show you our website. So this is our website that we have built. So these are the creators of Go. This is Robert Graysmyer, Rob Pike, and Ken Thompson, and this is the official logo for the Golang languages. All of this information is included in our proposal and our presentation, but um, Yeah, so there are some examples of code that I have over here. So this is a channel, you make a channel, this is an integer channel, and like you send a 1 to the channel and you receive the value from the channel. So this is there, and a lot of famous companies are using Go these days. There's a blog that we have mentioned over here in references, which is they handle 5 billion sessions in a day using Go. They have a Go script running handling that incoming traffic. Docker, Heroku, IBM, I believe AWS uses too. All the companies or products which require instantaneous scaling and need concurrency for their traffic or for their product, they use Go nowadays. So these are the examples which I will show you from over here. So I've logged into my puzzle account already, and okay, so let me see, let's go to goroutine.go. So let's do hello.go first. So hello.go. So this is a simple hello world function. You import the fmt package, and the main function is like the main function in any other language, like in Python or Java or C++, which runs or executes the package or the function or the file it is in, which prints in hello world. So if you want to run a program or build a program, a Go script, you say go build and say goroutine.go. This will build a file which we said will compiles to machine or the native code, and you just say dot and forward slash to run it. And oh, sorry, so it was hello. Okay, so it was hello.go. Yep, and to print it you say hello. So there it prints out hello world. Similarly, I have another function, another script, which is an example of Go routine. So what this does is it has a function. It has a function int, okay, which takes in an integer, all right, and it runs this loop for 4 times from 0 to 3, and 3 times from 0, 1, and 2, okay, and every time it does, it it prints a number, okay, it prints whatever the index is, and it waits for a random time duration from 0 to 250 or any amount of second that you get from this output. And going down, this function which runs 3 times is run another 3 times inside a Go routine. So there are parallelly 3 functions running from the main function, and they are outputting indexes from wherever they are. So it will be interesting to see the output of this function. So you say, I think I already built this, so you say go routine. So you see 0 1 2 0 2 0, this is already at 2, and 1 is still at 0. So this happens, and now everything has finished. So the order of execution is different. This is what a Go routine looks like. This is a sample Go routine, and this can definitely prove helpful. So this is still waiting for an input. So yeah, that ends. uh, another example that we have over here is of a markdown generator, or I think we have a channels demo too. Let me show you a web app that we made. So yeah, so this is a markdown generator. I hosted this on Heroku, and I'll show you the code for this thing too. All right, so say I do an h1 CS6320, and you make, and you say print. Let me just give it a style. Yeah, so there it is, it works. And this is a simple route right now. um, and I think I have its code on my GitHub, and let's see. All right, so go static file server, I believe. Yes, let me see, index.html. Yeah, so this is the static file that we see over here, this one. And the Go script, I think it's on the main Go. And over here, so this is the smallest code that I've ever written. So it listens on a port or gets the environment, gets the port from the environment if you have set it there. And these are handlers. Okay, HTTP package is inbuilt. This is the only dependency I have, and that is for creating the markdown from the raw input. So I have a route, and I have a handler for this one. So all these handle functions, they inherit from HTTP handlers, and they, this generates a markdown using the Black Friday dependency that we have. Yes, so all in all, Go was a nice experience to learn, and I feel it is more suited for script as a scripting language and as a DevOps language to say, but not more for a web developer. But it has certainly extensive concurrency features which are amazing to learn. All right, this concludes my presentation, and thank you very much. Don't tell me. All right, thank you.